the video stream that shows an embedded device, and that's coming live from Oslo. All right, then what is missing is recording, or do we already have that on? Post, yes, in progress. Okay, so we are good to go. Let's start. So welcome everyone to the webinar, Speeding Up Embedded Development. And today we're going to talk about Qt Enterprise Embedded. So we'll talk about basically the Qt developer offering for creating embedded devices and embedded user interfaces. We'll be doing this in 2 parts. So there's going to be, hold on, what's going on here? Okay, yeah. So there's going to be, there's me over there at the bottom. My name is Tuukka Auniemi. I work in Qt marketing. And then there is Andy Nichols over in Oslo, who will be showing how to do this in practice. So we'll actually have a lot of live coding, and we'll be playing around or fiddling around with the embedded device that you can see in the video screen. So I'll try to keep my overview part rather short, so you'll actually get to see this take place in practice. All right, I think we are, yep, we're all good to go. So agenda for today is here. So first of all, I'll explain to you shortly why have we done something like Qt Enterprise Embedded? What is our motivation for providing these certain tools we have, these additional libraries? Like, what are the problems we try to address with this offering? And secondly, I'll explain you shortly what are the contents of the product. As a developer, what kind of tools do you get? What kind of code libraries do you get with Qt? And then finally, we'll try to spend around 30 minutes with the live coding part by Andy, showing you how to do embedded development using the Qt Creator IDE in practice. We'll show you how to do device deployment, on-device debugging, profiling, UI designing, and so forth. And about the practicalities, this session is going to be recorded. So after the session, you'll actually get a follow-up email in a day or 2 that will contain a link to the webinar recording as well as a link to the slides. If you have questions during the session, you can use the Q&A panel, and you can send the questions directly to me, Tuukka, or if you accidentally send them to host, then the host will probably assign them to me. And I'll try to take questions here and there, but at least at the end, we will have time for questions. We'll try to spend around 60 minutes, including the questions, so we'll have plenty of time today. Okay, so why Qt Enterprise Embedded? Shortly said, creating embedded devices, especially nowadays with all the requirements around connected devices for Internet of Things and setting up complex cross-compilation tools and finding a suitable workflow is too complex. It requires, creating embedded devices requires very specialized knowledge, and it takes a lot of time and resources from all kinds of organizations. And especially if you're not already in an embedded industry, but you're doing, applications, and then you need to do an embedded device, it's awfully difficult to jump into embedded device creation if you've not already had extensive experience from it. So Qt as a cross-platform tool, or software framework has always been about making developers' life easier. And we want to do the same for embedded device creation. Qt has been used to power embedded devices, their software, for over a decade. But now let's say over the past 2 years, we put in a lot of effort in not just providing good programming libraries, but also tooling, direct device deployment, and the kind of convenience we have already available for mobile device application creation as well. With Qt, you've been able to directly deploy applications to mobile devices by just plugging in your phone to your computer and pressing play. That's the kind of convenience we want to provide you also for embedded device creation. One important reason for this is that if you think about software industries in general, the let's say for past 10 years, agile processes for creating software have become really popular. And like if you work with web technologies or mobile apps, it's a rule that things are done in an agile, a lean way, and you do things like rapid prototyping. That's really de facto way for creating software. However, in embedded industries, it's been very difficult to get a workflow, to get a good code, compile, deploy cycle to support rapid prototyping. And you've not been able to leverage the, the latest processes for creating software within embedded industries. So with the tooling we're going to show you, we hope that we're able to enable more agile processes also for embedded device creation and to kind of support these more modern ways for creating software. That it's you're not so locked into embedded obstacles when creating software. Okay, so what we're talking about is Qt Enterprise Embedded. What is Qt Enterprise Embedded? Let's start with our value proposition. Kind of what are the problems we try to tackle, and what is the value you get with Qt Enterprise Embedded? So first of all, we're talking about Qt, the cross-platform software framework. And for creating embedded devices, what you get with the Qt libraries is that you get a C++ framework. And the fact that it's C++ lets you create software that performs natively even on limited environments, maximizing the performance, and then the UI approaches of Qt have really been optimized to take full power of your device. We'll talk a bit about Qt Quick soon, and Qt Quick has been optimized so that it actually runs directly on top of OpenGL, so that it uses your GPU extensively, and you can, if you have a GPU in your device, you can actually get nice, beautiful, modern user interfaces. If you don't have a GPU, we also have other offerings for that. But it's about performance and creating modern user interfaces. Besides the actual code libraries, shorter time to market. The life cycles for creating embedded devices are really long. And with proper, you can do rapid prototyping. You can create device prototypes for usability testing for customers to accept or to give comments in an early phase of the project. So it doesn't need to be so bound to a certain waterfall model. Then one important part of our offering is the pre-built software stack called Qt. That's what we're gonna demonstrate a lot today. That earlier you had all Qt libraries in use, but what you had to do is you had to set up your own software stack for the target board. And basically, this was a work phase that easily took weeks of time to get a operating system, cross-compilation tool chains, all the middleware components in place, and only after that you were able to deploy to the device. So this is a part that we want to shortcut with our boot software stack. And finally, there are a lot of things for embedded devices you need to do in addition to just regular software creation. One of the examples is a virtual keyboard. So instead of needing to create virtual keyboards, we want to provide a solution for that too, along with UI controls. So you don't need to do everything from the scratch. We'll take a look at the virtual keyboard soon, but you can already see a bit of that on the video screen. Okay. Finally, the kind of a very unique part of Qt offering is that it's not only an embedded technology. Qt is truly cross-platform. So the same code you are using to write the software for your device, you can actually directly take into a mobile environment or a desktop environment. So what this allows you to do is that, for instance, if you're doing Internet of Things, you have an embedded device and sensors somewhere. And then on the other end, you want to make a mobile client to interact with that embedded device. You can reuse the same code, the same user interface, for instance, one-to-one on both of these parts. So while you're creating an embedded device as a free bonus, you'll actually get the code for the mobile remote application for free. Finally, Qt Enterprise Embedded is a product. So we're not just giving you a bunch of source code or source code project, but this is a product for commercial creation of embedded devices. So Qt Enterprise Embedded is our enterprise product for device creation, and with that you actually get a business relationship with us. You will get a roadmap. You will get full technical support assisting you with your application creation, as well as all possible bugs or obstacles you might face. So that's also an important part of our offering, that you're not alone with your device creation. Okay, let's take a look at our libraries, our developer offering on C++. So the Qt code modules, there are around 20 modules, and altogether around 700 C++ classes in those modules. Here on blue, you can see our GUI offering, and for non-GUI, you can see the green boxes. So if we start from the bottom, Qt is way more than just a GUI toolkit. You will actually get a high-level C++ classes for creating processes and threads, for instance. So instead of figuring out how to do multi-threaded application on this certain embedded platform, you can just use the high-level Qthread class. Or the same thing for networking. No need to write C sockets. You can just use classes QTCP socket or QUDP socket. Or actually with latest version of Qt 5.3, we added a module for WebSockets. So today you can actually make real-time bidirectional connections between devices or device and an application using the WebSockets API. So there are a lot of things underneath the GUI part, but for the GUI itself, I would say this is our main offering, the three parts here. The tip of the spear for embedded and mobile, let's say touch-based UIs, is Qt. There are three main reasons why Qt is really good for embedded UI creation. First of all, you can do beautiful modern user interfaces using Qt and with maximum performance. So Qt has really been designed for creating user interfaces. So you get views and transitions, custom UI components, styling APIs, scalable, resizable user interfaces. And all these are written with a high-level declarative language called Qml. So Qml as a language has really been made in a way that it's easy to try out things. So you can do rapid UI prototyping, and for embedded devices, even though, especially in industrial use, even though they are quite often used by trained professionals, the market requirements for these UIs have grown extensively in past 5 to 10 years. That it's no longer enough that it has a user interface, but the user interface needs to run 60 FPS. It needs to have beautiful view transitions and things like thin zooming and dynamic charting and so forth. So Qt has really been designed so that you can create all these requirements and that it runs with a good performance. Secondly, the workflow with Qt has been made so that you could work together with the UI designers and developers. So that the UI designers do not need to make a separate Flash prototype, for instance, and then the C++ coders would try to imitate that. But instead, together they could work with the QML language. Thirdly, what I really like about Qt that it's fun. It's fun and productive. It's in high abstraction level. You can play around with it. It's easy to try out things, test them in practice, and then alter them quickly if something doesn't work. It's also very easy to import external graphics there or directly export QML from Photoshop or GIMP. So we've done a lot of projects where we have an external graphics designer and integrating the changes that come during the process. It's very productive with Qt. Okay, so that's about Qt. If you don't have a GPU in your device, you're not really able to leverage Qt to its full potential. Then what you can do is you can use Qt widgets. Qt widgets are the most traditional UI approach of Qt. It's C++ based, full collection of customizable UI controls. This is mainly used in creating more traditional desktop look and feel. And they also can be customized really nicely into embedded touch-based use cases. However, let's say that normally they're used for a bit more static user experiences. And especially if you have a limited device power, like without a GPU, or you're running in a very restricted environment on a real-time operating system, then Qt widgets are normally the approach to use. Finally, as powerful as these native approaches are, we also want to we also want to welcome HTML5 as a first-class citizen into Qt-powered devices. So with the new Qt web engine offering that's based on the Chromium project, and it's available now in our Enterprise Embedded product, you can actually integrate HTML5 directly in your UI. You can mix it with Qt Quick, so you can do native stuff with your own UIs with native Qt Quick, HTML5 for the dynamic parts, and then even if you want to add a bit more flair, you can use OpenGL shaders for the web contents as well. Okay, there's a question that is GPU acceleration only available with Qt Quick. You can accelerate Qt widgets to some extent with um, uh, with OpenGL backend as well, or with the GPU, but Qt Quick is directly optimized for OpenGL so that the rendering order kind of maximizes the use of OpenGL and minimizes the context switches. So there's a dramatic difference between those two things. Okay, a bit about the tooling. You will see this in practice next. Our tooling is more or less integrated inside the Qt Creator IDE. So there are a lot of tools around Qt, build tools, UI design tools, deployment tools, but mostly you operate everything inside the Qt Creator IDE. What you can also do inside the IDE is that you can directly deploy to a device either using USB or IP connection. And with your connected device, you can do a direct device debugging, like on-device debugging or profiling. Um, Qt Creator has been pre-configured to run with the boot to Qt software stack. But if you have your own software stack and cross-compilation build tools, you can always configure Qt Creator to use those as well. So Qt Creator is not limited to just boot Qt, but it's easily configurable to your own build tool chains as well. Finally, if you don't have hardware in use, you can use the emulator, and it will show you the emulator action as well. So with the emulator, you can, for instance, simulate sensor events, and it's using more or less the same software stack components than the board would use. For the value-add components, what we provide is we provide pre-made UI controls, the Qt Quick controls, as well as the more industry-focused enterprise controls. Then we have the virtual keyboard. That's not only just buttons on the screen, but as you can see on the video screen, it's a full comprehensive keyboard solution. You can style the look and feel. It provides now, I think, 5 language setups. We will add a Chinese language in the next version, coming in around months. You can hook this into a word prediction engine, and yeah, no need to code your own virtual keyboard. And we have charts and data visualization of the components available as well. So charting allows you to do 2D charting, 2D charting. So that's basically both static and dynamic. And then Qt data visualization allows you to do static and dynamic 3D charting. And these are all exclusively available to Qt Enterprise Embedded and Qt Enterprise if you're doing desktop and mobile with the Enterprise license. These are also available for there, but I mean, Qt Virtual Keyboard is clearly something you mainly benefit of when doing embedded devices. There's also a question about SSL. So yes, SSL is supported in Qt networking library. So that thing is supported as well. Okay, then the boot to Qt stack. We'll show you this in practice next. The idea is just that after you install your development environment, you have a pre-configured Qt creator and a board already running Qt optimized software stack, and you're able to deploy immediately from your Qt creator to the device. So it's just like 1, 2, 3, and you're up and running. We'll show you this. You have to see this yourself. To go a bit more deeper into the contents of the software stack, so on the left-hand side, you have your development environment, what gets installed into your host computer. Currently, we support Ubuntu Linux. So you install the development environment there. You get all the Qt libraries, Qt Creator. You get an online installer. You get all these additional libraries like charting and virtual keyboard. You get the emulator. But then for the device, you get the boot to Qt software stack. And this comes in two flavors. Either one for embedded Android or one for embedded Linux. The embedded Android is basically a version of the Android stack that has been stripped down from the Java apps and the Dalvik virtual machine, as well as the Zygote process layer. So it features the Android kernel, Android middleware, selected parts of that. Then on top of that, it's directly running Qt applications. So Qt runs on regular Android phones and tablets, but this has nothing to do with that. This is an embedded device stack built on top of the Android kernel. The embedded Linux version is based on the traditional Linux kernel, and this is done using the Yocto project's proprietary recipes. So when you get started with this stack, and then later on, when you want to productize it to a certain product hardware or to your custom middleware, we give you all the tools and the Yocto project recipes for you to customize the stack to match your own needs. So you will basically get a fully working out-of-the-box solution for prototypes, but then you will also get the tools to customize the stack into your final needs. There's a question about a released version of Qt Enterprise Embedded. So Qt Enterprise Embedded is also running Qt 5.3. There's usually a couple of weeks in between the Qt release and the Enterprise Embedded stack release, but this time it was only 2 days. So Qt Enterprise Embedded is also based on Qt 5.3. Okay, I think now at this point we will take a look at how to do this in practice. One final clarification that we have these certain reference platforms. You can see them here. There's Google Nexus 7, IMX6, Raspberry Pi, BeagleBone Black. And these are the platforms for which you can download a pre-built image. When you install the SDK, you will get an image for these devices. But this is not the same thing than supported platforms. These are the pre-built ones. If you want to use boot to Qt in another platform, you can customize the stack either using Yocto project tools or our own Android tools for the Android stack. And for instance, for the Android one, we are working for an injection model where you can basically take any Android stack and you could inject the boot to Qt contents into an existing Android device. So basically, Qt would run pretty much on any kind of a Android device that lets you hack with the contents. Okay, I'll turn this over into Andy now. So Andy, you can show this in practice. Let's make you the presenter.
All right. So I'm gonna share my desktop here. Hopefully, yeah. All right, excellent. So I'm gonna switch over to Ubuntu Linux here, so I can demonstrate how this works. What I have here is Qt Creator open. I've installed Qt Enterprise Embedded with some Enterprise Embedded targets here. So I'd like to first start and show you how easy it is to create a new project that you intend to deploy to an embedded device. So from Qt Creator, I'm just going to hit the New Project button on the welcome page. Can select from the application templates the Qt Quick application. I'll give it a simple name here, like Hello World. And then I'll just go ahead and click the Qt Quick 2.2 component set. And then on the next screen, we're given a selection of kits. And in Qt Creator, kits are what you can think of as target platforms. So in our case, we want to select all of the embedded devices that we intend to deploy to. So since today we'll be using the embedded Linux IMX6 kit, that's our target device. We've already flashed an IMX6 device with the pre-built image to the SD card and booted it up, and that's what we've been showing on the video. So I'll go ahead and select that, as well as the desktop, just so we can see what it looks like locally. And I go to the next screen, and then we can finish that off. So once we've done that, the first thing we see is just a simple QML file that defines what user interface we have. In this case, it's going to be just a simple 360 by 360 window that has a text box saying Hello World in the middle of it. And we can go ahead and run that right now on the desktop so you can get an idea of what that looks like. Very simple white rectangle or right square with a Hello World in it. And if we click it, it should close the window. So without doing anything else, it is very easy to make this run on the embedded device. So the only thing we actually have to do is go down here to the kit selector and change our kit to the Boot to Qt 2.1 eLinux emulation kit. Emulator Kit. Oh, not Emulator Kit. I actually selected the wrong kit, so let's just go to the Projects tab and add the correct kit, which is the Embedded Linux IMX6 kit. And then we can go back and select the correct kit. Keep switching to the wrong one. Yes. So now that we've selected the right kit, we can see here we have this little icon of a device, and we've actually hooked up the device using just a USB cable. Maybe you can see that in the video. And you can see the little light green here, and that indicates that we're actually successfully talking to the device. And if we hit play now, we should be able to just deploy directly to the device and run our same application we ran on the desktop on the device. So let's just go ahead and do that. I'm going to hit the run button here. What will happen is it will cross-compile the application and deploy it to the device. And in a second now, we should see it running on the device. And it may be a bit hard to see because the Hello World is a little bit tiny, but you can see we're actually running the application here. So now that it's running over there, we could make a little bit of changes and maybe make it a little bit more interactive, since closing the application really doesn't make sense here. So looking back at the code, if we change the onClick event to actually change the color of the window, so we can say parent.color equals red. Whenever we actually touch our application now, it should change the background color to red. So let's just build and deploy this application again. and it's deploying. You can see down here. It's restarted the application. So if you look at the video screen, now when we touch the window, well, actually, it did not actually work because color is not a property of the parent window. So let's see if we can, maybe this will work. We're going to redeploy it again and see if we can change that background color. And again, it's deploying. And of course, yeah, that doesn't work. But anyways, I will show you a different example that I've written previously that is a little bit less contrived. So if we switch to this application called Temp Monitor that I've written earlier, I can show you a bit more. So I'll just go ahead and run the example and give you an idea of what to expect. So we're going to run it on the desktop. So as you can see here, there's a simple application that simulates the usage of maybe a more common embedded use case of reading from a sensor value and then displaying that value as part of the UI. So here we have two controls, one just the label telling you the actual number, and then a gauge control that actually visualizes that data. So to simulate this data, we're actually doing this from C++. So we just create a simple Q object that we'll expose to our UI. And here you can see that we're not actually reading from a sensor, but we're faking the data. Oops. Let's zoom in a little bit. We're just feeding a elapsed timer to assign value to get this undulation between -1 and +1. But it does demonstrate a more common use case of reading from what you would do on an embedded device. So here's the actual code. We pull in the sensor here, which is just the C++ object behind the scene, and then we hook up that sensor to the gauge value as well as the label value here. So we can take that same example and run it on our embedded device. We do that the same way that we did previously by going to Projects, selecting Add Kit in the corner here, and then selecting the kit we intend to run on, in our case the IMX6 Unix kit. And then we can just go ahead and build and run that. So we'll just go ahead and do that and show it running on the device. Again, it's building and deploying the device. And if you look at the device, you can actually see it running there. And so from there, I'll go ahead and demonstrate one of the next really neat features about the Enterprise Embedded. So if we go back to our C++ code, in this case the sensor simulator, and we set a breakpoint in Qt Creator, we can actually debug the C++ code remotely on the device visually in Qt Creator. So after we've set the breakpoint here on line 48, which should be run every 16 milliseconds, and then we hit the start debugging button here down in the corner instead, it should again build the application, deploy it, but now it'll be running GDB on the device, and we should be able to see the debugging as it happens. So now you can see it's starting up the application, and we've actually hit a QML breakpoint that I forgot to delete. But so now we've actually started the application, and we've entered the frame we're actually interested in. You can see down here the stack trace of where we're actually being called from. In this case, it's the timeout event of a Q timer because we're actually hitting this every 16 milliseconds. Up here, you can see the locals view, and again, this is running remotely on the device. And we can take this and we can step through our program and see these values changing. You can see here that the new elapsed value is 38,821, and as we continue, our actual value is changing here. So So we'll actually feed this into the UI, but this shows that the C++ debugging is working here. So the next thing I'd like to show, I'll just go ahead and remove this breakpoint and continue the application. If you look at the video, the application is run again. But the next thing I'd like to show while we're in the debugging view is the Qml debugging. So if we look here at this locals view, we'll see just a simple object here, and this ID represents the top-level window item. And we can actually, while the application is running, drill down into the object hierarchy and view the properties of the objects in real time as they change. So in the case of our application running, we can see in real time the value of the gauge, which is in the video, the thing undulating up and down. We can see that the value of that gauge is actually changing in real time here. So again, this is Qml debugging. And yeah, so that is one of the how Qml debugging works. So you're also able to do the imperative debugging. So if we set a breakpoint here, I have a mouse area over this entire view. And if we were to click in this area, I hope. Maybe it's not. Yeah, it's not set up to work right. But yeah, you should be able to hit any of the breakpoints inside of the QML as well. So that's C++ and QML debugging. Again, all of that done remotely. The next thing is profiling. So we have our app. We're running it. It works fine. But now maybe we're having a bit of performance issues. Maybe it's not as smooth. So if we want to break that down and see why, we can actually go to the Analyze tab here, and we can do some profiling on this application we have. So again, once this kit's set to run remotely, we just have to hit the Start button here on the QML profiler. Again, it's going to deploy our app and run it. If you look at the video, it's running here. It's running at full speed, and it's recording this in the profiler. We can see we've been running for about 10 seconds here, and I'll stop it. It'll give me all of the data here, and then we should be able to look at the analysis of our QML application running here. So we get this nice little graph in Creator that represents the profiling. Some of the things you can take a look at is the scene graph tab, for example. You can see the actual performance of the breakdown of the performance of the two threads of the scene graph, so the render thread and the GUI thread. And we can actually look at this and see per frame how much time was spent processing the render thread. In this case, it's roughly 16 milliseconds for the render thread, which is fairly normal, and the GUI thread, it's taking 11 milliseconds per frame, which is well within the 16 milliseconds we need to render at 60 frames per second. The other thing that's worth looking at here is the Compilation tab. This shows how long it took to do the just-in-time compilation of each of the components in our scene. And here, it doesn't really take a terribly long time for this very simple scene, 15 milliseconds here, 14 milliseconds here. But this is actually one of the things that where the QML compiler comes in, one of the new enterprise features, where if you were to do this, then these would be eliminated because they would be done ahead of time as opposed to during the application run. Okay, so that's the QML profiler. The next thing I would like to show is the emulator. So what I've been showing so far is just the hardware running itself here on the IMX6. If you didn't actually have hardware available or not enough hardware for your entire team, it's actually possible to run an emulator of this environment that we provide. So what we need to do to add that is to add the Emulator Kit. So if I add the embedded Linux emulator kit here and switch to that as my target, I'll now get this little extra button down here in the corner that'll let me start up a emulator. So I'll go ahead and do that. Move this out here. Should take a few seconds. It actually has to fully boot up the device, as it were. So, and you can see here that you actually have a control to actually simulate many of the things that you actually have on the device, maybe like an accelerometer, location data, any sensors like again, the accelerometer. And this is hooked into the emulator as if it were a real device. So any second now it should actually start up, and we should be able to deploy to this device. Yeah, so now it's ready. It's running a previous version of the application, but we can go ahead and run our version on it. Yeah, so there's our more simplified version. And yeah, so it may be a bit slower in the view. I think the desktop update rate in the actual stream is fairly limited, but it does run at full speed locally. So the next thing, in addition to the emulator that's really neat in Qt Creator, is the visual Qml Designer. So if I take that same scene that I've been showing already, or the simple gauge simulation, I can design I should get what you